Hello guys, today we're going to go over logarithmic expressions, functions, some rules. Also we're going to go over the concept of common logs and natural logs, and also how to convert logarithms to exponents and vice versa. So again, this should cover 3.2 all the way up to example 4. That's all you need to know, form 3.2 all the way to example 4. Now first of all, we're going to begin converting just a basic exponential function to a logarithmic, and note that these two processes, they are inverse. So a logarithmic function is pretty much the inverse of an exponential function. Let's say you have a particular base elevated to a y value, and that is equal to an x variable. When you turn this into a logarithmic function, you just put the base here, that what's on the right goes to the left, what's on the left goes to the right, and that's pretty much it. Now, using numbers, it's way easier to visualize. But again, the trick that I use to just do a straight up conversion is the base for the exponential function gets set as the base of the log. What's on the left hand side, which in this case would be the exponent, gets sent to the right hand side. And what's on the right hand side, which would be the answer, now becomes this value here. Let's use numbers, for example, to represent a conversion. And the one that they use in the book is, let's take the number 3, and let's take a marker that works. Give me 1 second. Have a whole bunch of markers here. Hopefully one of them will do the trick, because this one worked a couple of seconds ago. See? Nice. Okay, here we go. Let's say we have 3 to the 4th power. Again, 3 to the 4th power is 81. 3 times 3, 9 times 3, 27 times 3, 81. If I'm going to convert this to logarithmic, again, the base of the exponential function gets set as the base of the log. What was on the right hand side now moves to the left hand side, and what's the exponent that is on the left hand side now gets moved to the right hand side. And this is how you would express this exponential function. Okay, so 3 to the 4th equals 81 is the same thing as saying log base 3 of 81 equals 4. Now logarithms, if you just visualize them like that and not understand what's happening, it's kind of just difficult to wrap your head around logarithms. But the way I like to evaluate logarithms is ask yourself the following question. What exponent do I need to put on the base to end up with this number? So say, for example, I have log base 3, 9, without using a calculator. What number do I have to raise this by to end up with 9? 2. 3 squared equals 9. So again, that's probably the best way to just quickly do simple logarithms without needing a calculator. Let's say, for example, log base 2, 16. 2 times 2, 4 times 2, 8 times 2, 16. That would be 4. So what number do I raise this by to end up with this? That's how you get the answer to simple logs without requiring calculators. Later on, you'll see you're going to have, other numbers. Yeah, calculator there. Some of them don't need a calculator. Now let's go over evaluating the examples or the logarithms provided in example 1. And note that some exercises might seem like you need a calculator, but you do not. And you have to know how to recognize these issues. For examples 1, from all of them, you should be able to do them without using a calculator. Let's go over the first one. Kind of already did it. Log base 3 of 81. What number do I raise 3 by to get 81? What number do I raise 3 by to get 81? The answer would be 4. We kind of went over that one. Let's go over the second example. And again, oh my God, teacher, we got square roots. Doesn't matter. Doesn't matter. Use the rules of the radicals and the exponents, and you'll see it's quite simple. And these examples will help you learn the rules of the logarithms. So the second, B from example 1 says log base 5 square root of 5. I know. If you know what you're doing, it's not that complex. You should know that a number in a square root, so example, square root of 5, it's saying the exact same thing as 5 elevated to the 1/2. 1/2 represents square root. Remember, the denominator is the power of the root, and the numerator is whatever it's raised by, which in this case would be 1. So the question is real simple. What number do I raise 5 by to end up with 5 elevated to the 1/2? The answer would be straight up 1/2, because 5 elevated to the 1/2 will give me that number. Pretty simple. So whenever you see square roots with these problems, normally, not always, but usually, you have to turn it into exponential form and then work from there. So do not work with radicals. Next, let's go over example C, which for some reason gives many students a whole bunch of problems. They freak out, but it's not that difficult. We'll see. So log 7/1/49. Oh my God, teacher, we got divisions now. It's crazy. No, it's not that difficult. Now, whenever you're presented with a division, again, remember the rules of the powers and the exponents. 7 elevated to a negative exponent, all this does is flip that fraction and turn it into this. Yes or no? You send whatever's on the numerator to the denominator. Whatever in the denominator, we send it to the numerator. And you flip the sign. This goes from -2 to +2. And is 7 squared not the same thing as 1/49? So the answer to this is -2. You should be able to manage these types of problems without a calculator. Whenever you see a fraction, usually it's going to be a negative exponent. And that exponent should be the number that when you raise this by this number, you end up with the denominator. So let's say, for example, you have this particular, problem. Log 2/1/8. Again, fraction, I'm probably going to end up with a negative answer. And what number do I raise this by to end up with 8? It would be 3. 2 times 2, 4 times 2, 8. The answer would be -3, because 2 elevated to the -3 is the exact same thing as 1/2 to the +3, and 2 to the 3rd power is 8. So again, whenever you see fractions, just immediately think negative exponents. Okay, pretty straightforward. And the last one, which is easy, and again, it's going to teach you one of the rules. What number do I raise 2 by to end up with 2? 1. Remember, don't say 0, don't say a crazy number. Any number elevated to the 1st power is itself. And remember another rule. Any number elevated to the power 0 will be 1. Any number elevated to power 0 will be 1. We went over that in class last year on why it happens. Pretty straightforward. So that's it for, the examples and evaluating the logs that you don't need a calculator for. Let's go over the rules, which is on the key concept box on page 173, which is incredibly important because it's going to help you solve logarithmic functions. Right now, we're evaluating pretty basic logarithmic functions. Next week, we're going to be solving, isolating, and it gets rather complex. So you should know these rules. First of all, log B1. We went over this. Any number, doesn't matter, elevated to the power 0 will give you 1. Any number elevated to the power 0 will give you 1. So that one's pretty straightforward. The second one, if the base and this value here is the same, it will always be 1. Because again, let's do this with numbers. What number do I raise 3 by to get 3? 1. So whenever you see this expression, it's always going to be 1. What number do I change, 3/8 by, or what number do I raise 3/8 by to get 3/8? 1. Any number elevated to the first power is equal to itself. Any number elevated to the first power is equal to itself. So you should know that. When these two numbers are identical, that's the exact same thing as 1. So that takes care of that one. Let's go over the following key concepts. Whenever these two numbers are identical, they have to be identical, and this number is raised to an exponent, the answer will be that exponent. Let's put this into numbers and see how you're going to work with these. So for example, what number do I raise 2 by to end up with 2 to the 17th? And obviously, 17. Because 2 elevated to the 17 is equal to 2 elevated to the 17. So now, whenever we have these two numbers, whenever these two numbers are identical and you have an exponent on this number, the answer will be an exponent, or will be the exponent value. So for example, log 3 to the 8, you can change this expression for just 8. Pretty much these two cancels out and this becomes your answer. Very important. We're going to be using that one a lot. And also, we're going to learn how to exponentiate, meaning you're actually going to have a log as an exponent. And here, the exact same thing happens. If the base of the log is identical to the base, these two cancel out and the value is x. So for example, if I have 7 and as an exponent log base 7 of 6, these two cancel out and the answer would be 6. So that's it for the key concepts. Let's go over real quick example 2, A and B. Again, should only take a second. Log, and example A is a perfect example of something that could show up on a test. And there's a couple of ways to do this. Now, first of all, you could just do the math and know that 5 to the third power is equal to 125. So yeah, sure, excellent. The answer would be 3. Another way to visualize this problem using the rules that you learned is that 125 is the exact same thing as 5 to the third power. This base is identical to this number. They cancel out. The answer would be the exponent, or 3. So you can see there are multiple ways to work these problems, and you will be using these rules to solve for radicals, so be careful. The next one, again, also incredibly straightforward. 12 as an exponent, log base 12 of 4.7. This number is identical to the base of the log. They cancel out. The answer would be 4.7. That's it for example 2. Now, example 3, we're going to go over common logs. And in the calculator, that's what happens when you just hit the log button. When you hit the log button, you're using common logs. And all a common log is a logarithm with a base 10. But just to save time and to use like a standardized method, whenever you see log and no number as a base, that means that the base is 10. So for example, if I have log 100, I know the answer would be 2. Because I have a 10 here, and what number do I raise 10 by to end up with 100? The answer would be 2. So common logs are just logs with a base 10. Anytime you see log, base 10. Pretty straightforward, okay? And for example 4, natural logs. A natural log is a logarithm, but the base is the natural base, or E. Remember, E does not represent a variable. E represents a value, much like pi. It's in the calculator, 2.7 something. I don't know it. You don't have to memorize it. It's in the calculator. Go ahead and use it. But just know that whenever someone mentions natural log and they're expressed like this, ln, that's log with a base E. So in some cases, you will need a calculator. Log, like if I say natural log 17, calculator. If you are able to cancel out the log using the rules, then you don't need calculators. I'll give you a couple of examples. E natural log 6. I know that this base is E, this is E. They cancel out, the answer would be 6. I don't need a calculator for that. Likewise, natural log e to the 17. I know this base is E, I know this is E, they are the same. They cancel out, the answer would be 17. And also many of the other rules. ln 1 would be 0, because any number elevated to the power 0 will be 1. And also, just ln e would be 1. Because what number do I raise e by to get e is 1? And you should also know one of the rules, that this should cancel out and become a 1 because the numbers are identical. So that's pretty much it for solving logarithms, or not solving, evaluating logarithms. So we're not solving yet per se. That's all you need to know from 3.2 examples 1 through 4. We're not going to focus on graphs or transformations, but note that all the transformations that apply to normal polynomials also apply here to logarithms. Vertical stretch, vertical compressions, left or right shifts, reflections, compressions, everything works exactly the same. That's why I'm not going to spend time going over that again. Just focus on learning the rules, being able to... One of the important things in this chapter is recognizing when you need a calculator and when you do not need a calculator. It's going to play a big part in the test, okay? Note again, sometimes you will have to use calculators, other times you will not have to use calculators. You should know when. Have a great day. I'll see you tomorrow.